This is section 3.4, part 2 video. We are asked to construct a truth table for the given statement. This is a conditional statement. So here's our PQ column set up. We need to do Q, if Q, then not P. So we do need a column labeled not P before we can actually do the Q not P. So not P means we negate the P column, so the two T's become F's and the two F's become T's. Now to do Q, to do if Q then not P, we're looking at this right here under the conditional connective. Remember, the only time the conditional is not true is if the premise is true and the conclusion is false, which is what this is right here. This is false. These other ones are all true. Statement here is made up of 3 simple statements, and that is why we need 8 rows. We've got 3 different letters, gives us 8 rows. The P alternates with 4 T's followed by 4 F's. Q goes 2 T's, 2 F's, 2 T's, 2 F's, and R alternates TF, TF, etc. Now we've got to build into this bigger statement here. Look through here and notice that we have a not R, so we're going to need a not R column. We have a not Q, we're going to need that column. That takes care of those individually. Now looking inside the parentheses, you need a not Q, implies P. Put that all together with the not R, or if not Q, then P. So these are all the steps we're going to have to go through to get to this final statement. So not R says look in the R column and change all those T's to F's and the F's to T's. So this goes FT, 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 FT. Not Q tells me to look at this column and change all of those. So all of the T's become F's and all the F's become T's. Now, not Q implies P. If not Q, then P. That is this column going to this column using the conditional. So if not Q, then P. Conditional is false only if you have a true premise and a false conclusion. A true premise followed by a false conclusion. So I need to find any place I have a T in this column and an F in this column, which there's a T followed by T, T followed by T. Those are F's to begin with, but these last two are T followed by F, T followed by F. Those are both going to be false. These other entries will all be true, because the only time the conditional was false is if the premise was true. This is my premise column, because this is not Q in the front. That's my premise column. So the only time the conditional is false is if the premise is true and the conclusion is false, and it would be those 2 rows. Now we want to put together not R, which is this column. That's my not R. We're putting that together with this column using OR. Now, for an OR statement to be false, both statements must be false. An OR statement will be false only if both statements are false. The only place I have false, false between these 2 blue columns is right here. False, false. That will give me a false, which means all these other entries should be true. Remember also with OR, the other way to look at OR is if you have at least 1 T between the 2 columns, it's going to be true. There's 1 T, and that's why this is T. I have 2 T's, that's why that stays T, etc. You can look at those. There's another way to do a truth table rather than build it like the book does, and I'm going to show it to you, and you can use it if you want. Sometimes you have to do it the way the book does it because in your homework, this is laid out for you. All of this is laid out for you, and you must fill in the columns with the trues and the false. However, sometimes they are only interested in you finding the final column. So I'm going to show you what I think is a shortcut. it requires you to understand order of operations. So this is the way I do these truth tables. And I do have all of the PQR stuff written in front of me so I can refer back to this. I think about my order of operations. My order of operations would ask me to do this not Q implies P. So I need to write right underneath not Q my entries for not Q. So this will be false, false, true, true, false, false, true, true. That's my not Q. Then I'm going to just rewrite my entries for P. True, 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 false, 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 false. Order of operations tells me to do what's inside the parentheses first, which is what I'm getting ready to do. I'm going to do these two blue columns using the conditional rule. The conditional is false when the premise is true and the conclusion is false. So look for any time you have T followed by F, T followed by F. The two places I have T followed by F are right down here. So under the conditional connective, I would have F's for those two positions, and I would have T's for the rest of this. The next thing I do is I circle this, and I also use these different colors like I'm doing on this video for you. I circle this because that is my result column for the parenthesis part. I'm not looking at any of the blue anymore, I'm looking at the red. I could even right now scribble that out or erase that, but I don't want to do that. I want to leave it here. So here's the result for in the parentheses. I need to look over here at not R. So I can write down the not R. All of my not R's would be to take all of these and flop them. So this goes to false, true, false, true, false, true, false, true. The last thing I need to do is this OR. So if I can do OR for the two red columns, I should circle this just to kind of visually show you what I'm doing. I'm doing OR with the two red columns, just those two. And this is where you could erase that. You could cover this up with your pencil or something or a piece of paper so that all you're looking at are those two red columns. And you might write your answer in a different color. So I'm looking at the red columns with OR. The only time OR is false is if both of those entries are false. The place I have where both of these entries are false is right here. I'm a little bit off on the line. It would have been better if I had drawn in some lines, but false, false gives me false. Every other one of these has at least one T true. And if you look back, this is the exact same result we had doing it the other way, which was writing it all out. So this was just another way to do your truth table if you like this. It does take up less space, but you do have to follow your order of operations, and then you have to maybe cover up or scribble out what you don't need. So let's do a couple more. We're going to do this one the book way, so we need to set this up. We will need P if and only if Q. We'll need that entry. And then we have this one. So this one is not that bad to rewrite. It's just the real long ones, like we've got one coming up in a minute that I like my way better. So if and only if, the only time if and only if is true is if they are the same. True, true will give me a true, and false, false gives me a true. Otherwise, it's false. So now I am looking at this column as if then with Q. So you have to visualize going backwards. So for the regular conditional, the only time the conditional is false is if the premise, this is my premise column, if the premise is true and the conclusion is false. So you have to think about going this way. Premise is true, conclusion is false, means this will be false. All these other entries will be true. All right, here's a big monster that's going to require a lot of writing out to get everything in place. Now, notice when you go through here, you do need a not Q. You do need a not P. There's a plain old Q and P, which we have. Then we can do this inside the parentheses, which is not Q and not P. But then we need the negation of that. we have to have a plain old Q and P. And I'm not going to have the room to write all this in. All of this is that entry right there. So, let's see if I can draw some straight lines. The negation of Q just says take this column and change those around. False, true, false, true. Negation of P, take this column and change those around. So false, false, true, true. Now I need to do these two columns using the connective and. The only time an and statement is true is if they're both true. So this is true, and these are all false. But I need the negation of that. That's what this is, the negation of this column right here. So negate all of that will give me true, 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 false. Now I'm dealing with just this part right here, Q and P, plain old regular Q and P. So I'm going back to these two columns. And again, the only time an and statement is true is if both of the individual statements are true. So for this P and Q, this would be true, and the rest of these will be false. And the last thing I have to do is this under the biconditional to this. So the biconditional between these two columns is what's going to go here. The biconditional is true only if these two entries are the same. So true, true would give me a true. False, false would give me a true. And these last two things have to be false. So this is my final column for this truth table. And what we were asked on this is to use this truth table to determine whether the statement is a tautology, a self-contradiction, or neither. Remember, tautology is all of these true, so it's not a tautology. Self-contradiction is all of these false. It's not a self-contradiction, so it must be neither. Let's look at the same thing my other way to do the truth table. So you might like this a little better. Let's just give you a little practice at doing the other way, and then of course it becomes your choice for setting it up whatever way you want. So what I do when I look at this, I'm starting right here with my not Q. My not Q is looking at this column and changing those around so it goes false, true, false, true. My not P is negating this column, which is false, false, true, true. And I need to do and between those two things. So the and between those two things, the only time an and statement is true is if these are the same. So this is true, and the rest of these are false. I need to negate that. That would be my resultant column for what's inside the parentheses. The negation in front of that says change all of those reds. So all of those reds get negated to T, 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 F. So that's where I am right now. I even sometimes put a star on it to remind me that's the answer for that part of it. Then I come over here to do Q and P. So I'm just rewriting Q. Q is T, F, T, F. P is T, T, F, F. And I'm doing an and between those. And the only time an and statement is true is if both are true, which is this. So true, false, false, false. I'm going to circle that. That's my answer for within those parentheses. And now I need to do this column, because that was my answer column for this part of it, under the biconditional to this red one. So the biconditional is true only if they are the same entry. So true, true will give me a true. False, false gives me a true, but these other two are false. So to me, this takes up less room, but you got to know how to do your order of operations. That's the only disadvantage. If you're not comfortable with this, then go ahead and write out everything like we did on the last way. And we're still answering the question, is it tautology, self-contradiction, or neither? It is still a neither.